Good morning, students. Now today we are going to start our 15th lecture of chapter number 2, that is units and measurement, and we are continuing with the topic that is application of dimensional formula. And in that application of dimensional formula we have completed our first application, that is conversion of one system of unit into another system of unit. In that one example we have completed, I have just solved, that is how many dynes are there in 1 Newton. Now one example I have just be given you for your homework, that how many erg are there in 1 joule, and I hope that you have solved this question, but I am just solving this question again. If you have faced any of the problem in this question, you may sort it out from this lecture. Okay. So our question is how many erg are there in 1 joule. So before start to calculate this question, first thing which you have to be remember that the unit which is given in the question is of which physical quantity, because this thing we have to be understand, we have to be remember, because of this only we are able to find the power ABC, we are able to find the physical quantity, and through that we are just identify its MLT, the dimensional formula also, which is very much helpful for solving this question for this application as well. So here the unit is joule. So we know it very well that joule is the unit of work as well as energy. Okay. So for the energy, the first thing is that we will just write in the solution form, we will write the given values, that what values have been given in the question. So first of all, the N1 is your 1 joule. So 1. N2 we have to calculate it down. Okay. Now if we talk about the value of its energy, so energies have the dimensional formula, force into displacement, force kg meter per second square into meter means displacement, so kg meter square per second square, so kg meter square per second square, m1 L2 T minus 2. Okay, force into displacement. So from here power A is equals to 1, B is equals to 2, C is equals to minus 2. Okay. Now moving forward, we have to be write the values of M1 L1 T1. So M1 L1 T1. M1 is your 1 kilogram, because here we are considering this joule as a M1 and this is in the form of MKS. 1 meter 1 second. Always remember one thing, that this is not be confirmed that always the MKS value will be written on the numerator side and the CGS value will be written in the denominator side. No, the value which we have to be calculate in either of the system of unit, that should be written in the denominator side. Here we have to be identify the unit in the CGS system of unit, that's why we are writing them in a denominator. Okay, and the given value which is in the MKS system has been written in the numerator. If it was opposite, that the MKS we have to be find and CGS value has been given, then the CGS value should be written in the numerator and the MKS value should be written in the denominator. It's completely depends upon the question, that what value, what system of unit we have to be calculate. It doesn't mean that the same type of the process has been applicable in each and every type of the question. No, it completely depends upon the pattern, the condition of the question. Okay. Second, I am taking for the CGS for the erg. So M2 L2 T2. So M2 is your 1 gram, L2 is your 1 centimeter, T2 is your 1 second. Clear? Now I am applying the formula. What's the formula, beta? I am writing the formula once again, but no need to write the formula again and again while solving the question. So N2 is equals to N1 m1 upon L1 to the m1 upon m2 to the power a L1 upon L2 to the power B, T1 upon T2 to the power C. Now I have to put all these values in the formula. Okay, so in this formula, N2 is equals to, the value of N1 is 1, M1 is 1 kilogram upon 1 gram, value of A is 1, L1 is 1 meter, L2 is 1 centimeter, power is 2, T1 is 1 second, T2 is also be 1 second, power is minus 2. Clear? Now we have to be convert them in the CGS form, because the CGS value we have to be calculate. So N2 is equals to 1 into how many grams are there in 1 kilogram? 1000. Power 1. How many centimeters are there in 1 meter? 100. 1 centimeter, power 2, and this will be 1 second upon 1 second, power minus 2. Now we have to be calculate it further. 1, when the 1000 gram has been divided by 1 gram, only the 1000 with the power 1 we have find. 100 centimeter divided by 1 centimeter, then it was 100 only, power is 2. 1 second divided by 1 second is your 1, power minus 2 does not affect the value. Then N2, here 100 square is there, means 4 zeros are there, 4 zeros are here, 3 zeros are here, so total 10 to the power 7, 1, 2, 3, 4, 5, 6, 7. So 10 to the power 7, and this will be your answer. It means what we have said, that 1 joule contains 10 to the power 7 erg. Remember beta, sometime in the exam it was directly asked as a question that how many dynes are there in 1 Newton. Always remember there is 10 to the power 5 dyne is present in 1 Newton. And how many erg is there? 10 to the power 7 erg is there in 1 joule. Okay. So this is the question which I have given you in your previous lecture. Now moving ahead with our second type of the application, and the second type of the application is checking the dimensional consistency of equation. But when you have just go through with the NCERT book, remember the NCERT book of a physics is little bit complicated. Complicated means the topics are not be written properly, not be maintained properly, and the theory portion is very much which is given. From that I am just make the theory for you, that it will be utilized for you and it will be understanding also by you. Okay, so I am just be elaborate all the things, and the topic I am just be the, here the topic has been given in the paragraph form, in the written form, and here I am just be make this topic in the point wise section, so you are better for your better understanding. Okay, so second application is checking the dimensional consistency of equation. Now this application doesn't have any kind of the formula, particular formula, only the thing which is there for this type of the application is through the numerical form, because in this what we have to do, we have to just an equation has been given and we have to be test that consistency, that whether this equation is consist or not. So we have to be test the consistency of the equation and we have to be proved. Okay, if it is proved wrong, then no issue, that you have written the equation which is given is not be true, not be proved, okay, is wrong. But if it is proved, okay, it means the equation which is given is correct and need not be actually an exact equation, doesn't matter the question which has been given is a particular equation will be there, no, but the value should be proved properly. And how we will prove the value? As same as that we are proving in the maths also, that LHS equals to RHS. Okay, so for your better understanding, I have to first solve one example so you can understand the thing. How we will solve this example? First of all, I am just writing the question, the example, that let us consider, but you have to remember the method only of this, all this application, because it doesn't have any kind of a particular formula. Let us consider an equation, and what is the equation beta? Equation is half m v square is equals to mgh. If I am not wrong, you are well aware about this equation, because I think you have studied about this equation in your 10th standard. Half mv square is the formula of kinetic energy and mgh is the formula of gravitational potential energy. Okay, and you know the energy and energy both are equal in this form. We have to be calculate that LHS equals to RHS, we have to be prove here. But the things for calculating, for solving this second type of the equation of checking the consistency of equation, in this we are well aware about this symbol, that which symbol denote which physical quantity, because if we are not be getting a proper understanding of this symbol, then you are not be able to put the proper dimensional formula, and if the dimensional formula you have put is wrong, then entire question will become wrong. Okay, so you have to be well aware about this, and which is already given in the question, that where m is the mass of the body, v its velocity, g is the acceleration due to gravity, and h is the height. Now check whether this equation is dimensionally correct. You have to be checked that whether this equation is dimensionally correct. Here m is the, so in the solution of this equation, we have to first write the dimensions of each side. So I am first of all writing the equation, that what the equation has been given in the question, and the equation is half m v square is equals to m g h. This is your equation. Now what we have to do, first of all we have to write the dimension of LHS, or what is the dimension of LHS. So in the LHS we have the formula half mv square. So half is a numerical term, it doesn't have any kind of a dimension, so we are not considering the value half. M is the mass, mass is having the unit kilogram, it means it has the m1. L and T is not be there, so I am not writing it down. Or either if you want to write, you will write L0, T0, doesn't matter. Now the second, this is your velocity. So velocity is what beta? Meter per second. Meter means L1, second means per second means -1. Always remember, while calculating the dimensional applications, you have to be well aware about dimensional formula also. So L1 T1 T minus 1, it has the power 2, square is there. Okay, so I am just combine and make its one equation, one MLT formula. So M is 1, here is no any kind of M is there, so I am not writing it down. If you may write down, then you may write like M 0. Okay, 0 means there is no value of mass is there. So M1, here L1 into square is this, so L2, T minus 1 into 2 is your -2. This is the value of LHS. Now we have to be write the dimension of RHS. So the dimensions of RHS are, dimensions we have to be write it down beta. So how we have to be write the dimensions? Like, what is the RHS value? mgh. So m is your mass. Mass means kilogram. So power is 1, m1, L0, T0. G is acceleration due to gravity. So this is acceleration. Acceleration means meter per second square, velocity upon time. So meter per second square. Meter means L1. Per second square means time -2. This is the height. H is for the height, and height is having the unit meter. So meter means length L, and it has the power 1, so 1. Now I just make and combinedly I have to write it down. M1 is there, L1 plus 1, 2, T minus 2. Now look at the dimensional formula of LHS and RHS, both are same. Okay, so what we have to be write now? So LHS is equals to RHS. Hence the given equation is dimensionally correct. Okay, so like this we have to be check the consistency of the equation, the whether the equation is dimensionally correct or not. Okay, now question I am just be giving you, you have to be solve that question at your home as the homework. Okay, an example I am giving you for this type of the application, and the question is the SI unit of energy is joule equals to kg meter square per second square. You know beta, force into displacement, force kg meter per second square into displacement, it will become meter square. M1 L2 T minus 2. That of speed V is meter per second. You know beta, the unit of speed is meter per second, and of acceleration unit is also be given. And what is the unit of acceleration beta? Meter per second square, meter per second square, m0 L1 T minus 2. Now which of the formula for kinetic energy kinetic energy K given below, can you rule out on the basis of dimensional arguments M stands for the mass of the body. You have to be checked. Okay, so for that the equations has been given. A is your K equals to m square v cube, means velocity cube. B, K is equals to half m v square. C, K is equals to mass into acceleration. D, K is equals to 3/16 m v square, and E, K is equals to half m v square plus m a, means mass into acceleration. Okay, so you have to be correct the formula or the equation, but remember that the both side have the same dimensional formula of the equation. Okay, and you have to be find the dimensional formula by added, you can add them, by subtract them. Okay, you have to be calculate all the things. So if you have solved for the first one, so what was there beta here? M square velocity cube means L3 t minus 3. This one m1 L2 t minus 2. This one m1 L1 t minus 2. This one m1 L2 t minus 2. This one m1 L2 t minus 2 plus m1 L1 t minus 2, then you have to be add them. Now you have to be check which one is the correct one. Okay, because this will not be have any kind of proper. Always remember, for calculating the dimensional formula they will be in a multiplied form. Okay, so you have to be find which one is the correct formula which can manage with this equation of energy, means m1 L2 t minus 2, which of these are having the same dimensional formula. Okay, which number you have to be find it down. Clear beta? Okay, now moving ahead with the third number of application, which is now the third number application we will start in our next lecture, and with the next lecture we will complete our chapter. So I will just be giving you one more question that was interesting and the basic question. You have to be use the concept only, your mind. This is a mind type, mind using question. Okay, a hot question like this. So in this the question is like this beta. A famous relation in physics relates moving mass m to the rest mass m naught of a particle in the terms of its speed v and the speed of light c. This relation, there is a hint, brief about this relation, that this relation arose as a consequence of spatial relativity due to Albert Einstein. A boy recalls the relation almost correctly, but forget where to put the constant c. He writes the formula like this: m is equals to m naught 1 minus v square 1 by 2. Okay. Now there is a one boy who are just be writing the famous equation, a relation of a moving mass and the rest mass, in which the velocity of a particle and the velocity of the speed of a light has been given, and this famous relation is your spatial relativity theory, which has been given by the Albert Einstein. But he was just, when he was writing, it was almost writing the equation correctly, but he had just be forgot to write the value of c, and if he was not be able to find where the value of c has been written, and he write the value like this, the formula like this: m upon m naught 1 minus v square to the power 1 by 2. Now what you have to do? You have to just find that where the value of c has been written. Guess where to put the missing c. Even this question is related to your second application, that's why I am just be giving you this question for your homework of LHS equals to RHS. Always remember, when we are just making the LHS equals to RHS, then that principle is known as principle of homogeneity, that I will just be told you in your next application as well. So this is the homework that you have to be do. Okay, these two numerical, okay, and these are the easygoing numerical. In the first one you have to be checked that which of the given 5 options is having matched the dimensional formula with the dimensional formula of energy, that is m1 L2 T minus 2, and in this you have to be find the guess where the point value of constant c has been written in this equation, which is written by a boy, which is almost correctly, but there is the missing of c, constant of a speed of light, that you have to be mentioned here. Okay, clear? So in our next lecture we will start with our third application. Okay, thank you, that's all for today.